Hi, today I want to talk about collets, but you probably know that already from the video title. They're really useful, but there's a problem with them. There are so many different types. And with getting my new lathe, I got this problem again. This lathe wants to use B32 collets, like this one. The problem with these is, as far as I am aware, only Schaublin ever used these anywhere, and even they used it in just a handful of machines. So the used market for these is, let's say, very close to non-existent. This one I bought new for a little over 50 euros. If I wanted to buy the full set, new, it would be over 3,000 bucks. I don't want to spend that kind of money. So just don't use collets, right? Independent four-jaw chuck, and that's good. But these are really convenient. I kind of really would like to use collets. And then I had an idea. Of all the ones you see, the one that's closest in size is this 5C collet. And I actually have a full set of 5C collets from my Weiler lathe. So the question becomes, can we make an adapter so we can use these collets in the Schaublin? Short answer, yes. There are actual 5C collet chucks that you can just mount a backplate on, mount it on your lathe, and it will work. They cost a few €100, that would be fine. They work a bit like a scroll chuck. You have a key and you turn it, and the scroll turns, and that just threads these on. What that means is two things. For one, it takes forever to screw one in and out. And second, it's manual. I have already a pneumatic drawbar in the Schaublin, so I kind of would like to use that one. And there, the question if that is possible or not was slightly harder to answer. Wasn't quite sure at the beginning. Let's jump into cut and see what I came up with. We can see here now a rough representation of the spindle nose as I've measured it. Then here the drawtube with the maximum movement, also as measured on my machine, and a B32 collet. So this is as the machine is intended. You can see it's bearing on that cone and on a journal relatively far back inside of the nose. In between, there's no actual contact between the collet and the nose. This is relatively usual for this type of collet. So if we now get rid of the B32 collet and get the 5C one in here, we can see there's kind of a problem here. The journal might actually just about fit, but the thread is a completely different one, and the cone shape as well. So this will not work. We definitely need some kind of adapter to adapt the threads from the 5C one to the one used in the Schaublin. Let's get it in as well. This is what I came up with. It has, this journal size is the same as B32. It has a little bit bigger one to actually bear on the front side as well. It has the same thread as the Schaublin, and in the front it will get the same thread as the 5C collets, obviously. So with this we can design a piece that adapts between the short taper of the spindle nose and the 5C collet. The outside is really just aesthetic mostly, but being very slender in the front might help with some parts that are kind of bell-shaped to still fit on here. In addition, there's an anti-rotation device that's usually just a pin, but a pin would have had to go through a very big section here, and I didn't fancy my chances of drilling a 3mm hole that deep and actually still hitting the exact middle of that hole. As we have a plan now, let's start making parts, beginning with that drawbar adapter. For this part I used a piece of 42 chromoly in the QT state that already had a 20mm hole in it. That was from an older project. I started with the internal contour for the collet side thread. As this is an imperial sized thread, I had to grind one of my metric inserts to match. The thread cutting sounded horrible. I assume I did a bad job at getting the reliefs on that regrind right. It took me multiple adjustments to get the sizing correct. But after some adjustment the collet fit easily. This may have been a bit loose, but especially on the collet side I wanted at least somewhat loose fit. Then I turned the outside to its final diameter, breaking a corner on the last pass. Recutting that pass left a little bit of a step that I later removed with file and emery on my manual lathe. Here is the part halfway done. The side outer diameter fits fine. The thread is now really good. For the second side I had to cut two shoulders first. One with the same diameter as the cylindrical part of a B32 collet, and a second one a bit smaller for the thread. This thread is a relatively coarse sawtooth profile. I had a cutter for this already. It is few and far between for me, but sometimes the odd tools that you have to make will become useful again in time. This thread went way smoother than the first one. I still had to adjust after the first go, but it sounded way better. And the second run already yielded a nice and close fitting thread. I then added a thread relief by just jogging the tool manually. I did that so the drawtube could fully seat against the created shoulder. Later I turned the inside to a 23.3mm size. This is just a bit bigger than the capacity of my biggest 23mm 5C collet. I did that off camera. With that, this part seems functional so far. Let's get to the big part of this project, the main body. For this part I also used chrome moly. As I don't have any heat treatment equipment, I went for the quenched and tempered variant of the material, so the collet taper is at least somewhat wear resistant. I started by facing and then cleaning the outside diameter, still leaving some material to be turned finally at a later stage. Then I started drilling out the center. The smaller drill went fine, but stepping up I had some difficulties getting the right speeds. My bigger drills shattered a lot. I reground them multiple times, but had a really hard time getting anywhere. Initially I wanted to go all the way through, but with the difficulties I had, I stopped when I thought I was deep enough for the short taper to go in. If you have seen my last video, you may already see where this is going. As I wanted to rough out the taper, this happened. I'm still not completely sure what happened here, but my best guess is that I was measuring the drill depth wrong and ignored the drill point. So that the tool that I used for drilling went in and encountered solid material right at the end. After that, I had to reattempt the same operation. The first cut was nerve-wracking, but it sounded good, so I at least gained back some of my confidence and stepped up the feed rate. And got the chip to actually break. The rest of that operation went fine. With the taper roughed out, one of the more challenging parts of this whole project came up. This camlock is a dual contact connection. This means that the taper has to be sized extremely precisely, so both the taper and the end face make contact when installed. But it is not trivial to measure this. I went by cutting and testing multiple times. For this I left the part in the forjug and dismounted both together, so I could hold up the whole thing to the spindle nose. With an extra set of hands, the gap between spindle and new taper could be inspected with feeler gauges. I just recut little bits at a time until my thinnest shim stock could barely pass between the spindle nose and the part. My hope is that the pull studs will be able to elastically deform the taper and pull the whole chuck so the faces actually touch. While editing this, Stefan Gotteswinter has actually released a video on how to measure short tapers on backplates like this. I wish he would have done so like 2 weeks earlier. Let's look at what we have thus far. The surfaces look very good. We have one impact crater from the incident left over, but I think that will actually disappear when I put in the features for the pull studs. Let's do that now. It's really just 3 pockets. Then spotting the needed drill locations. Here I also cut light chamfers so I don't have to deburr later. Then the feature for the anti-rotation plate. Sorry for the bad camera angle. I then drilled the holes on the drill press and hand tapped the threads. I used the pull studs of an existing chuck to finally mount the part on the spindle nose directly. This will hopefully be the last setup on this part. Let's get rid of the bulk of the outside material. I initially stalled the machine, but reducing the feed I got it to cut. Playing with the feet a bit more, I found a raid that broke chips but did not stall the machine. Then one more pass to clean up the contour. Now to the inside. I cut a profile still 1 mm shy of final dimensions and measured the journal deep inside with a 2-point inside gauge. And took 2 more passes, measuring and adjusting in between. Here I'm measuring after the final pass. The gauge is zeroed at 31 millimeters, so we want to see minus 0.750 on the indicator. Yeah, we are 400s over. But there really is too much work in this part. So let's go on with it and see how bad these 400s really are. The piece to inhibit the rotation of the collet that will be screwed in the back of the main body was by far the easiest part of the build. I used a piece of scrap stainless and run a contour with some stock to leave. And an additional cleanup pass. The 2 screw holes were just spotted on the mill to be drilled out later. Then I removed most of the waste material on the bandsaw and brought a part to final thickness on the mill again. It needed a fair bit of deburring, but fit fine with no problems. The 3 parts we had to make are done now, and I have to say I'm quite positive about how they look. We have the collet adapter itself with the short taper. The draw studs we just borrow from an existing chuck I already own. And with this, there's really nothing else to do than install it in the lathe and find out how precise or imprecise it really is. But before we find out how bad this is, if you like this content, consider subscribing. For installation, I first screwed in the drawtube in the machine as normal. This fixes the tube so I can apply torque to get the drawtube adapter in. This needed more torque than I think would be optimal. I may reduce the biggest diameter on the part by a few hundreds. This should not impact the accuracy of the overall system at all. To get it fully seated, I used a collet in the front as a handle. As I made the thread on the collet side intentionally looser, it came out easily without unscrewing the drawtube side. Now I can install the main body, making sure to align the punch mark I made with the index mark on the spindle nose. With the body installed, the runout on the collar taper can be measured. I dismounted and remounted the part multiple times to get a feeling for the repeatability. It seems to be absolutely repeatable, at least with my most accurate indicator. The runout itself seems to be about 4 thousandths. I'm not sure where these thousands came from, but I think I can live with 4 thousandths. With a 3mm collet mounted and a piece of ground silver steel in it, the runout on that could also be measured. I could not believe my eyes, as I could literally not make out any deviation at all. Setting the indicator again to double check, I could see maybe 1 thousandth. This is less than the runout of the pure taper. I had to test another collet, as this was really unexpected. I had a short section of 20mm silver steel, so I mounted that and got closer to 15 thousandths. This is much closer to the results I expected. It seems that the quality of the collets influences the runout much more than my adapter, which is an absolute win in my books. Okay, and once again we have arrived at the end of a video. The measuring part actually quite a bit better than I was hoping for. Having no runout at all in the 3mm case was very likely just a coincidence. That's why I did a second test with this short 20mm bar. I would like to do a longer test bar to see how good the angle really is. I don't have one at hand at the moment, so that will have to wait for a later date. But so far, visually, I think this part is one of the nicest looking parts I have ever made. And that's not because I'm this good, it's really, this lathe is just turning beautifully. And I think really I don't have to buy any B32 collets anytime soon. This seems to be well within what I usually need. 1.5 hundredths. I mean, I tested 2 collets. There might be one in there that's a bit worse. There might be one in there that might be a bit better. That's fine. 4 thousandths runout on that phase. And that is very repeatably. I did retry it like 5 or 6 times. And it was very close to 4 thousandths every time, again and again and again. So I think this short taper came out quite okay, even though I think it's a bit smaller than it should be. So there's a bit more space between that face and the spindle nose than there should be, but it seems fine. And yeah, I think that's all I have for today. I wish you a nice week, and I hope I will see you again.